Hey everyone. So today we're going to be doing the AP Calc BC 2013 FRQ number 6. And if you don't know about the layout of the AP Calc BC exam, usually the 6th FRQ involves power series or Taylor polynomial, something of that sort. And that's true for this question, so we're going to dive in. Really quick, I have the question pulled up on my computer separately, so if you want to follow along, I would recommend just Googling AP Calc BC 2013 FRQ number 6, just so you can follow along and learn to the best of your potential. Additionally, I'm going to try to give all the key points of the question like on the paper, but if you want like the best experience of solving the question, I'd recommend Googling it and following along with me. Also, I'm really sorry for this awful setup. It consists of me putting my phone inside a cup and trying to record, so I'm going to be working to improve that in coming videos, but I'm pretty new to this, so this is what we have for now. Hopefully it's not too bad and you can understand okay. Okay, so the first question says P sub n is the nth degree Taylor polynomial for f of x about x equals 0, and it gives us some information to start out with. F of 0 is equal to -4 and P sub 1 of 1/2 is equal to -3. And what we're supposed to do is show that f prime of 0 is equal to 2. Now, if you don't know, the structure of a Taylor polynomial, or how you build one, is you start with f of the center, c is the center, f of c, and in this case, that's just 0. C is 0, it's told that it's centered at x equals 0. So it's f of c plus f prime of c times x minus c. And this is the whole Taylor polynomial we have to deal with right now because it's just a first degree Taylor polynomial, which is what it tells us, because it's P sub 1. So plugging in the information we know f of 0 is equal to -4, and f prime of 0 is what we're trying to find. We're trying to prove that it's equal to 2, and then x minus 0 is just x. So we're left with this right here. Now, P sub 1/2 is essentially plugging 1/2 in for x, right? So P sub 1/2 is equal to -4 plus f prime of 0 times 1/2. Now all we just have to do, we just have to solve for f prime of 0. So to do this, I would multiply both sides by 2 to get rid of this 1/2. So you get -6 equals -8 times f prime of 0. So -6 plus 8 is 2 equals f prime of 0. And that's what we're supposed to get, so we're good. Okay, part B. It says it is known that f double prime of 0, you see that, f double prime of 0 is equal to -2/3, and the third derivative, I'm just going to write that, of 0 is equal to 1/3, right? P sub 3 of x. Now, this is actually pretty simple, because the third degree Taylor polynomial of something is equal to, as we said before, I'm just going to automatically plug in 0 for c because we understand that it's about x equals 0. So it's f of 0 plus f prime of 0 times x minus c, or well, just x. I said I wasn't going to do that, times f double prime of 0 times x over 2 plus third derivative at 0 times x squared. Sorry, my brain is being jumbled right now. Divided by 3 factorial. Okay. So, we already know a lot of this information. So P sub 3 of x is equal to -4 plus f prime of 0. We already learned that was 2 from the first part, so it's 2x. It gives us that f double prime is -2/3, so we have -2/3 x squared over 2, and then f triple prime is plus 1/3 x cubed over 3 factorial. Now, we can simplify this a bit if we want, just by dividing and expanding the factorials. So P sub 3 of x is equal to -4 plus 2x that's going to be 2 over 6, so 1/3 x squared plus 1 over 3 times 6, so 1 over 18 x cubed. So that's it. That's just part 2. This question is actually pretty simple. Now the third part is a little bit harder, but it's still not that bad. So the function h, can you see that? Yeah, okay. The function h has first derivative given by h of, so I'm just going to write h of x there. So h prime of x is equal to f of 2x. And it is known that h of 0 equals 7. And find the third degree Taylor polynomial. Just going to write that. Find the third degree TP for h about x equals 0. Okay. So the third degree Taylor polynomial of x we just found. It's right here. So the third degree Taylor polynomial for x of 2x is that, but you're just plugging 2x in for x. So p sub 3 of 2x equal to -4 plus 2 times 2x minus 1/3 times 2x squared plus 1 over 18 times 2x cubed. Okay, we'll just simplify that further. So p sub 3 of 2x is equal to -4 plus 4x minus 1/3, or I guess 4/3, x squared plus 2 cubed is 8. 8 over 18 is 4 over 9. 4 over 9 x cubed. Okay. This might have not even been necessary to do this, but we're just going to do it anyway. Okay, so now what we have to do is to, so h prime of x is equal to f of 2x, but we want to get to h, so that means we have to integrate both sides. Because if we integrate h prime, we get to h, so we have to integrate this one as well. We have to integrate f of 2x. So, and f of 2x is being represented by this third degree Taylor polynomial. So that means we're going to have to integrate this third degree Taylor polynomial term by term. Okay, so we're going to say q sub 3 is third degree Taylor polynomial for h of x about x equals 0, just so we can keep the notation consistent. Okay. You see that okay? Okay. So what are we going to do now? Now what we have to do is q sub 3 is we're going to have to integrate this term by term. So q sub 3 of x is equal to -4x plus 4x squared over 2 minus 4/3 x cubed divided by 3 plus 4/9 x to the 4 over 4. Wait, but it was an indefinite integral, so we need to add a constant, plus c. So we need to find the c value, but how are we going to do that? Well, this is where that last piece of information they gave us, that h of 0 is equal to 7, comes into play. Okay? So if we plug in 0 for all of this third degree Taylor polynomial is approximating h of 0. So if we plug in 0, we should get 7 is equal to, plugging in 0 for all these x's makes them go away. So 7 is equal to c. So therefore c is 7. Okay? So now we just have to write that out. Is equal to, we have a 7 in front, we're just going to move that in front. 7 minus 4x plus 2x squared minus 4 over 3 times 3, 4/9 x cubed. And that's it, because we only wanted the third degree Taylor polynomial. So that would be our final answer. So hopefully this all made sense to you. This question honestly wasn't too bad. It was only, first of all, it was only 3 parts, and they were all pretty simple, I'd say. So this is probably one of the easier Taylor polynomial, Taylor series questions on the AP Calc exams, but it was a question nonetheless, and hopefully this went well for you, and I hope you learned something from this video. So thank you so much for watching, and we'll see you next time.